All right, so this week we're going to be learning how to solve equations. So we learned last week about really expressions, right? A pattern represented by numbers and variables. Right, so we were just doing things like this, that, all those are all expressions, right? So now we're moving on to equations. And equations are just when two expressions equal each other. Okay, keyword equal, right? Equal equation has that equal in there. When two expressions equal each other. So it might look something like that, right? Where before it's just an expression, there's no equal sign. Now we have an equal sign here. We're saying this is equal to that. So these two are the same thing. They're equal to each other. Right? And then we're going to start breaking down how do we solve these equations. Okay, so we're going to start really simple at first. Right, so when you're solving, okay, so kind of separate. Okay, so we're doing really simple. We're saying the expression x minus 7 is equal to 15. Okay, we have an equal sign. We have two sides now, so this is an equation. Before, we couldn't, when you just had something like this, we couldn't figure out what x was, right? But now we actually can figure out what x is because now we have context. We know that this side is equal to this side, and so we can actually solve this equation, right? And what solving means figuring out what x is. Okay, because remember, variables are just numbers. We just don't know that number yet. Now we have enough context so we can actually figure out what the variable x is, right? So it's a number, we can figure out what that number is. Right, so this one I kind of did because it's hopefully a little bit simpler. You can maybe do it in your head. And you just have to think, what number minus 7 will give me 15? Okay, so if you can do it in your head, it's fine. If not, just know it's going to be 22. Okay, so, and if you plug that into a calculator, right, if I plug through using substitution, if I put 22 into x, right, 22 minus 7, I get 15. So it checks out, right? We want it to equal 15. Okay, so I just figured out what x is. X is 22. There's only one right answer. We're just going to be working with linear equations. We'll get to quadratic ones later. That's when we start having like x squared things, but we're not going to do that yet. That's later on. Okay? So, how did you, if you did this in your head, or let's do another one, maybe in our head. So, if you think like x plus 2 equals 7. So you just have to think, what plus 2 would give me 7? That would be 5, right? 5 plus 2 equals 7. Therefore, x has to equal 5. Okay? So the way that these are actually being solved in your head, whether you're aware of it or not, is through what we call a transformation. Okay? So let's do the first one again. Okay, so transformation, in order for me to figure out 22, I know it's like a number minus 7 gives me 15. That means if I add 7 to 15, I should get the right answer, right? So if I add 7 here, I will get 22. Okay? That means I need to get rid of the 7 on this side I'm doing the same thing to both sides. Okay, so I transform it because minus 7 plus 7 cancels out. 15 plus 7, I'm going to carry down my equal, and I get x equals 22, which is what I did up above, just in my head. And when you have these simple ones, you might be able to just do them in your head. But when numbers get bigger, a little bit more complex, you might want to write out all of these steps. Okay, so what we just did is called a transformation. And I'm going to break it down really simply. Right? A transformation is when you do the exact same operation on both sides of an equation. Okay, so this is one of those where I'm going to just use numbers, not variables yet, to explain this. Right, so let's say I have 7 equals 7. I mean, obviously we know that's correct, but I'm doing this for example's sake. So if I have two things that are equal, in order, you could think of it as like I have 7 apples, you have 7 apples, right? If I want to keep it equal, say you got 2 apples, right? So maybe you got 2 apples. In order for us to still have the same amount of apples, I would also have to get 2 apples, right? That's the only way we can keep it equal to each other. Right, so I add 2 on both sides of the equation. So see, I added 2 on the right side, I added 2 on the left side, and it kept it the same. So I still have 9 plus 9. 9 equals 9, right? And you can do this any way you want. Maybe I take away apples, right? If I want it to stay, if I want both of us to have the same amount of apples, we'd both have to give up 2 apples in order for the amount of apples to be equal between each other, right? So that's what transforming is. We're doing the same math operation, adding 2, subtracting 2. It doesn't have to be 2, it can be any number you want, right? To both sides to keep it equal. So as long as I'm doing the same thing, it's gonna stay equal, right? Which is that's the main key here, because it's an equation. I'm trying to keep both sides equal. Okay, so when we have an equation that actually has variables, right? Right, I want to find the solution, right? The solution, the number you can substitute into x to make both sides equal. Or sometimes it's to make both statements true. You might hear it said either way. Okay. So this is probably one of those you can do in your head. You can probably think, oh, well, what plus 3 would equal 9? That would be 6, right? But let's do it the transformation way. So to find the solution is going to be, what is x equal, right? I want to reform my equation to just be x equals some kind of number, right? I don't know what this number is. That's why I'm going to solve it and figure it out. That's going to be my solution, x equals. So I want to rearrange my equation. So the way I can do that is by transforming. So if I want to get x by itself, like I did over here on one side, I need to get rid of this 3. How can I get rid of this 3? Well, if you think of adding opposites, right? Plus 3, positive 3, minus 3, they're going to cancel out, and I'm going to get rid of the 3 on the left side of the equation, and I'll just be left with x. Right, I'm just kind of carrying it down. This cancels out to 0. But if I want to do that, I have to, the only way I can do it so that my equation stays equal is if I do it to both sides, right? So I'm going to also subtract 3 from the right side of the equation. Carry down my equal sign. I get 6. Right, and then I get exactly what I want. I get my solution right there. X equals 6. Okay, so let's just do some examples. Throw in some negative, right? So here I want to get x by itself. That's your goal. That's how you get your solution, right? X equals a number. So in order to do that, I need to get rid of my 21. So that means I want to subtract it. If I'm going to do it on one side, then I have to do it also on the other side, right? I'm left with x on the left side, carry down my equal, and on the right side, negative 14 minus 21 is negative 35. Ooh, sorry. Okay, so we have this one. Again, I want to get my x by itself. Okay, so I need to get rid of this 12. This time, though, you have to pay attention to the sign. It's no longer, up here it was like plus 21, right? Now it's minus 12. So you just have to think, what's the opposite of subtraction? Well, addition, right? And then that way, minus 12 or negative 12 plus positive 12, that gives me 0, right? So I'm going to do the same thing on the other side. And that actually gives us 0 too. So that leaves us with x equals 0. Don't get fooled by that. That's a totally valid answer. 0 can be a right answer. Okay, 0 is still a number. It just means you don't have positive of whatever it is. You don't have negative whatever it is. You just have nothing. Okay, so for this equation, the answer for x is 0. All right, and you can actually check all of your answers. I mean, this just if you are not sure if you did the equation right, if you solved it correctly, you can always check, right? So we have our original equation. I just solved, and I know that x equals 0, so I'm going to plug 0 into x. And then I should end up with a true statement where the left side equals the right side after substituting, right? So I'm going to substitute that in. So I have 0 minus 12 equals negative 12. 0 minus 12 is negative 12, right? Does negative 12 equal negative 12? Yes, it does. Therefore, the statement is true, right? It checks out. Statement is true. X does, in fact, equal 0. Okay, and you don't have to check. I usually only check if it's like it was a really tricky, complicated problem and there was a lot of steps to it, and I'm just like, maybe I didn't solve that correctly. Maybe I made a wrong step somewhere in there. Also, for your homework, I'm pretty sure I only picked whole number answers. You shouldn't be having fractions as your answers. So if you you solve a problem and you end up with a decimal or a fraction, that's probably a good sign that you should check it, because I'm trying to keep it as simple as possible. So no fractions, decimals in your answers. Just do one more. Yeah, so I want to get x by itself. I'm going to add 14, right? Negative 14, the opposite is adding 14, so that they cancel. If I'm going to do it to one side, I have to do it to the other to keep the equation equal, right? Then I carry down my x. 2 plus 14 is 16. So there's my answer. And then let's just do another check for good measure, right? X equals 16, so I'm going to plug that in. 16 minus 14 is in fact 2. 2 equals 2, so we did this correctly. This is the correct answer. Right? So I'm going to stop here.